When it comes to time series analysis in Pandas, there are two important terms that you need to understand. The first one is timestamp. Here I have Apple's intraday stock price chart, and each of the price point is associated with a specific instance of time. For example, here $161.22 is associated with August 10 2 p.m. and this August 10 2 p.m., which is an instance of time, is called timestamp. But when you're looking at Apple's revenue for 2016, for example, that revenue corresponds to a time duration or a time period, which is January to December. So this one is called time span. And in this tutorial, we are going to talk about time span, period, and period index. I have a Jupyter notebook launched here by running Jupyter notebook on my command prompt. And first, I'm going to create the 2016 yearly time period. And the way you do that is by running pd.period, in the brackets specify the year, and you can see here that it created this period object. ADEC means the period is annual, which is ending in December. If you look at all the properties of this period, you will find many useful properties, such as whether this year is a leap year or not, what is my start time, and what is my end time. So let's try few of these. The first one is start time, which as expected is 2016, 1st January. The end time, if you have any guess, would be 31st December. You can also create a monthly time period by supplying the month here, and you can say if my frequency is month. That created a monthly time period. And you can run start time and end time on it, and it would be the 1st January, and the end time would be 31st January. Now the good thing about period objects is that you can perform arithmetic operation. For example, in this month, if I add one more month, it will give me a month of February. Now, if this month was, let's say 2016 February, or let's say 2016 December, and when you add m+1, it will take you to 2017. So it is fully aware about the calendar, and it will give you the expected result. Let's create a daily time period now. For daily time period, you would say, let's say 2017 February 28. By default, if you don't specify frequency, it will use this daily frequency. It will try to automatically derive the frequency here, and if you want to be explicit, you can just supply a frequency parameter like this. Now when you add one day into this daytime period, it will take you to 1st March. Now you would think that whether this period object is aware about leap year or not. So for example, 2016 was a leap year, and when you add one day into 28th February, instead of giving 1st March, it gave you now 29th March, because it knows that this was a leap year and it had an extra day in the month of February. So this is pretty smart. You can also create weekly time period, hourly time period. So for example, this one you can convert into hourly if you just do this and specify an hourly frequency. I will just call it H. It created an hourly frequency And if you do start time and end time, so start time is this, end time would be the end of that hour, which is 23:59. Again, when you add 1 hour into it, it will take you to 29th February. So this is fully intelligent period arithmetic. You can achieve the same result by using pandas offset like this. So in this hourly time period, I can add pandas offset hour 1, and it gives me the same result. You can add like 5 hours, 10 hours, whatever, you know. And here also you can like subtract. You can say, okay, give me the time which is 6 hours prior to my original time period, and it should work as expected. In financial time series analysis, people often use quarterly time period because companies report their financials based on quarterly. At least in US, most of the companies are quarterly fiscal reporting companies. 1 quarter means 3 months, and typically you have 4 quarters in a year. Our typical quarter starts from January, ends in March. The second quarter starts in April, ends in June, and so on. Okay, so let's create a quarterly period. So for example, I'm creating 2017 Q1. It created this quarterly time period. DC means quarter ending in December. Okay, so when you do quarter plus 1, it gives you the second quarter. You can do start time, end time. It will give you the expected result, which is for 2017 Q1, it will be 1st March and 1st January and 31st March. Now, there are companies which has little different fiscal year, the fiscal year which doesn't align with calendar year. For example, Walmart, their fiscal year ends in January. Most of the companies are January to December. This particular company is February to next January. Okay, so if you are processing fiscal data for Walmart, how would you create the quarterly period? Well, in the frequency, you would specify Q ending in Jan. Now, what this means is my period is ending in January, and you can verify that by printing start time, end time. So here you can see that 2017 Q1 start time is actually, don't get surprised, this is true, it is in 2016 February, because their year would end in January, so it has to start much early. Okay, so their Q4 will be November 2016 to January 2017. You can also use as frequency function to convert this frequency into some different frequency. So let's say I want to convert this quarterly frequency into monthly frequency, and you need to specify how do you want to do it. So I would say just use your start time, and when you do that, you get a monthly time period, which is February 2016. You can also use end time, which will give you April 2016. So this is how you can convert one frequency into other frequency. Okay, so let me remove this and let me show you something else. So you can now create a second period, okay, which is, let's say, 2018 Q2. Okay, so my Q2 is this, and you can perform arithmetic between two periods. So if you have two periods, you can do addition, subtraction, etc. And it will tell you that there are 5 quarters between this Q2 and this Q. Okay, now you cannot perform arithmetic operations on frequencies that kind of doesn't make sense. For example, quarterly and hourly. If you try to subtract hourly from quarterly, I think it's not gonna work. So you have to supply some sensible input to your arithmetic operators. If you go to Pandas documentation, it will list all the possible frequencies which are supported. We used QGen. There are weekly frequencies also. Typical week ends on Sunday, so you would use W sun frequency. But for countries like Egypt, where the week ends on Saturday, because their weekend is Friday, Saturday, so for Egypt, you would use WSAT frequency to represent a week. Okay, now we are going to create a period index. So if you remember from our datetime index tutorial, there is a date range function which you can use to create datetime index. Similarly, these periods can be used as an index into a data frame, and the index which has period is called period index. So let's create some index right now. So pd dot period range. Let's say I'm creating periods between 2011 and 2017. Okay, and my frequency is quarterly. So it created all these periods. So I have all the quarters between 2011 and 17. Now again, for companies like Walmart, you would use QGen, so it will create these kind of periods. Now you're wondering why when I say 2011, it started with 2011 Q4. So this argument 2011 means calendar 2011, but that calendar 2011 gets translated into fiscal 2011, and that will be equivalent to 2011 Q4. I know it's confusing, but let's look at that a little bit in more depth. So I'm going to print the start time and end time of 2011 Q4. Okay, so let me print end time now, and here it says that the 2011 Q4 start is in November and end is in January. Okay, so since the fiscal year is ending in January, that particular quarter will be Q4. Okay, so that's what this 2011 Q4 means for Walmart. Okay, and since you say I want periods between 2011 and 17, it will start with 2011, the first quarter, which is quarter 4 for Walmart, as represented by these dates. If you don't want to give start and end date, you can just give number of periods. So I can just say I want to generate 10 periods, okay, with frequency this, and that will do the trick. So this is pretty much same as date range function. Okay, now you can import NumPy module and use NumPy's random function, random number generator, to create a series. So when I create this series, it looks like this. So I am using a period index here and filling in some dummy values. When you type ps.index, it will show you a period index here. Now the benefit of period index is you can do partial operations. So for example, here I'm seeing all the periods between 2011 and 14. If I want to retrieve only 2011 quarters, I can do it like this. If you are interested in retrieving quarters between 2011 and 13, you can specify a partial index like this, and it will return you the expected output. Here the index is period index. If you want to convert this into datetime index, you can do it easily by calling toTimestamp function. This created me a new series, but the index here is actually DatetimeIndex, and you can confirm it by calling pst.index, and you can see that it is a DatetimeIndex converted from PeriodIndex. You can convert DatetimeIndex back to PeriodIndex by calling toPeriod method. Okay, and then you get a PeriodIndex back. Okay, now we are going to do some fun exercise. So I will go to Google Finance and download Walmart's financial. So WMT is Walmart's ticker, and if you click on financial, this shows the financial results published by Walmart company. Okay, it has very important metrics such as revenue, gross profit, and so on. And if you're doing a financial analysis of a company, these metrics are very important. To make the exercise simple, I downloaded these results into this simple Excel file, and I have only 3 metrics here. And in the header of this Excel, I have the financial period, and the rows represent the metrics along with their values. And what we are going to do is we are going to transform this particular Excel sheet into this format, where I have transposed the table and set my periods as my index, and I have these 2 new columns called start date and end date, which represents the starting and ending date of that particular financial period. And since this is Walmart, you can see that the start and end date are not non-conventional. They are as per Walmart's fiscal calendar, which is ending in January. Okay, so just to summarize, the goal of this exercise is to transpose the table and create these 2 extra columns. Okay, so let's first import this CSV into a data frame, and my data frame now looks like this. Okay, now I'm going to call setIndex function because my line item column is a regular column and I want to make that an index, and the way you do it is by calling setIndex. You need to supply in place parameter to be true so that it modifies the original data frame, otherwise it will just return you the new data frame and original one will not be modified. So now I have my line item set as an index, and I can use df.t property to transpose my table. So this .t will just transpose the table, which means it will convert rows into columns and columns into rows. So now I have my periods as an index. If you print your index, you will notice that it is of type object. I want to convert this index into a period index, and the way to do that is very simple. You will call pd.periodIndex function on your original index and supply a desired frequency. So my frequency here is qgen, and when I print period, you can see that it converted regular object type into a period index type. Okay, now let's create the start date column. In data frame, whenever you want to create a new column, you will just have that column assigned to something. So you will say df start date is equal to something. Now what is that something? So I want to take my index and I want to iterate through all of the index elements, and since these elements are period objects, I want to call start time on these objects. And the way to do that would be by calling map. So when you call map, it takes a function as an argument. So I need to supply some function which can take these elements and return start time from each of these elements. Now, the quick way to define a function inline is by calling lambda. So lambda x dot start time. You can notice that start date column is created and it has an appropriate start time. So 2017 Q1 is typically started in 2016 February. Okay, so this is working as expected. You can create end date column in similar way by calling end time, and here you have a desired result. You have start date and end date columns created as expected. This is all I had for this tutorial. The link of this Jupyter notebook is provided in the video description below, so you can download it from GitHub, you can play with it, and I would highly recommend using Pandas for financial time series analysis, because we just saw that it makes a lot of things easier. You know, it makes all of the time and date related operations extremely easy. You get things ready-made, and the benefit of this is that you can focus on your business logic instead of worrying about the syntactical details and reinventing the wheel again and again. Thank you very much for watching. I will see you in next tutorial. Bye.